Hello, I'm going to be explaining some of DynamoDB questions, just five of them for today. Now, the first question is, what are the two types of primary keys? And I explain. Now, we have two types of primary keys in DynamoDB. We have what we call the partition key, then we have the partition key, and what we call the sort key or the hash key. So the first one is what? The partition key, and the second one is the partition and sort key. So if you are picking a primary key in DynamoDB, you have two options. You have the option of specifying a single key, which becomes your partition key. And partition key decides where the location that your data is going to be stored at. That is what partition key determines. So that implies that any item, if two items have the same partition key, they are going to be stored in the same location. Now that's the first option. The second option is the partition key and sort key. So you specify the partition key. You also specify what we call the sort key. So the partition key allows DynamoDB to locate where the data is stored, and the sort key allows DynamoDB to search or query that particular partition. So we have two types, the partition key alone and partition and sort key. So that's the answer to the first question. And the next question is why do we create secondary indexes? Now, we know that we have indexes. We create indexes so that we can do faster query. Indexes allows us to perform faster query on a particular attribute. Now, why do we create secondary indexes in DynamoDB? This is because in DynamoDB, you can only perform query on your primary key. So, you can only perform query on your primary key. Now, let's say I want to perform query on a non-key attribute, on an attribute that is not part of my primary key. For me to do that, I have to create a secondary index. Now, that's answer the second question. The third question, how does DynamoDB achieve high availability? Now, every table that you create in DynamoDB is being stored across different availability zones. So, your your table your table is guaranteed to be always available because if one AZ goes down, the other AZ starts to serve your traffic. Now, what are the next question? What are the differences between the global secondary index and the local secondary index? Now, remember we talked about indexes. They allow us to search non-key attributes. Now, local secondary indexes have the same partition key as the table on which they are being created on. So let's say we have a table of students and the partition key is the student's ID and the student email. So let's say that the student ID is the partition key, the student email is the sort key. Now, let's say we want to be able to search by names, so we are trying to create a secondary index. Now, if we are going to create a local secondary index, the partition key of our index must be student ID. The sort key can be different. Now, for global secondary index, the partition key can be any key. It doesn't have to be the student ID. It could be anything, and the sort key can also be anything. And now that's the first difference. The second difference is the partition key has a maximum size of 10 gigabytes because they are sharing partition with the table itself. But the global secondary index has no limit of such. The next difference is the global secondary index, you have to provision its own throughput. So its own RCU, its own its own write capacity unit has to be provisioned for it. But for local secondary index, it shares the same capacity units with the table on which it's being created. And you can only have 5 global secondary index per table. Those are some of the differences. Now the next question, which is going to be the last question, is what's the difference? Explain eventual versus strong consistency. Now, what is these are two types of consistent read consistency actually. Now, if we are trying to, let's say, if you have a table and you write to a table, it takes time for the change for the updates to take place. If we are using eventual consistency, once you write to the table and you try to read immediately, you might get old data. Let's say in a table you have an item called A and you update the item to B. If you are using eventual consistency, you might if you are using eventual consistency, you might and you try to read, you might see A again instead of B, which you updated A to. But if you are using strong consistency, DynamoDB only returns the updated result. So it returns B. I want to point out that if you are using eventual consistency, you you may get the updated result, but it's a probability, it's not guaranteed. But if you are using strong consistency, it is guaranteed that you will get the updated result. And also eventual consistency uses lead RCU than strong consistency. So that's the difference between the two. One immediately gives you the updated results and one takes a couple of seconds or a second to actually give you the latest results. So that's it for the 5 questions. Thank you.